On the back side of this lesson, we're looking at some problem solving with tangents. So we've got Martha. She's visiting Murney Tower in Kingston, Ontario. She's standing outside the tower at point A, 20 meters from the center of the building. Shown in the diagram right here, right? We've got the 20 meters right there. She walks along the path of the tangent from A to B. So she's walking from A along to B. Okay. And then she walks around the building along an arc that subtends a central angle of 30. Okay. So she's walking along there, right, from B to C. And they're telling us that the distance BO is 8.5, and they want to know how far did she walk in total. So we've got two parts. We've got to figure out from A to B, and then from B to C, and together that will make our total distance there. The easiest part to solve for would probably be the A to B section, letter X, because that's the idea of a tangent, and we've got some Pythagoras going on there. In particular, 8.5 squared plus x squared has to be 20 squared. Our hypotenuse is across from the right angle, so x, or sorry, 20 is our hypotenuse. And to solve this, we've got to rearrange it a little bit. So 20 squared minus 8.5 squared. Put it in our calculator and we'll get 327.75. That's what x squared is, so we square root that and we end up with 18.1 for a section of the walk from A to B. To figure out letter Y, that's an arc. Now we haven't done arc in a couple of days, but just to remind ourselves, if I want to find an arc length, I have a formula for it. Our formula for arc is Y equals 2 pi r, the circumference, times the portion of our circle, our sector angle, out of 360. So we're told that 2 pi, the radius is 8.5, the distance from B to O. We are told that her walk subtended an angle of 30 degrees. That would be her sector angle. And that's a portion of our overall 360 degrees. Put that all into our calculator and we end up with 4.45. And therefore, the total distance she walked is made up of the first part from A to B, which we said was 18.1, plus B to C, which we said was 4.45, giving us a total of 22.55 meters. Okay, so we're sort of combining ideas in this one. Tangents and arcs. We move to the very last question. Okay, give it a try. Watch the video, see if you got the right answer. Okay. We got Alvin at point A on the circumference of a circular area. So we need ourselves a circle here. All right, we've got a circle. Okay. He's on the circumference, which means he's on the point on the outside. That's point A. And it's 3 meters from the center of that circular region. Ben is at point B, outside the circle, 5 meters from the center of the circle, and 4 meters from Alvin. Okay, so let's put him down here somewhere. He's 5 meters from the center of the circle and 4 meters from Alvin. And they want us to explain how we can determine whether the line segment A to B, remember B is Ben right here, is it a tangent or not? So really what they're asking us is this a right angle? Because if that's a right angle, then AB must be a tangent. Well, how could I prove that? Well, if it is a tangent, I could use Pythagoras. Pythagoras would have to work if this was a tangent. Okay, 5 would be my hypotenuse. 3 and 4 would be my A's and my B's, right? So I got A squared plus B squared equals C squared. If I try this in my calculator on the left-hand side here, it comes up to 25. 5 squared, also 25. Well, I've now shown that 25 is the same as 25, which means that this must be a tangent. So we'd answer that with AB is a tangent to the circle. Okay. That takes us to the end of tangents and the end of geometry.